Hello, YouTube. It appears that the people at Nathan Oakley's debate channel, Nathan himself, the alleged surveyor, it's so hard to believe this guy is a surveyor. He cannot do simple mathematics. He doesn't seem to have any idea about distances, and measurements, but never mind. Anthony Riley, Ranty, and anybody else who hangs around there. They completely misunderstood the WGS84 ellipsoid and have doubled down on their misunderstanding, having their misunderstanding pointed out to them in videos, on their live stream, in chat, on their live stream. They have produced another video entitled Flat Earth Debate QED WGS84. And in this video, Chris, the surveyor, explains how he generated a model in Blender which has the Earth having, or at least he claims, the WGS84 ellipsoid is in fact only 33 meters thick. It has a height of 33 meters at its thickest point. Now, these are the figures relating to the ellipsoid, and what Chris has done is use this flattening factor, and I'm going to let him explain how he used it. So I'll play the video. I'll pause it occasionally because he makes some mistakes, which I will correct as he goes.
Here, switch screens. It turns out to be this, more or less. Because you can see, I did it to scale, of course, but I took the 6,378,000 kilometers.
So he says he took 6,378,000 kilometers. I think he meant meters. What he's actually entered there in the box is 6,378 kilometers, which would have been 6,378,000 meters. However, a minor point, he maybe just misspoke.
On the X and Y axis, and in the Z value.
So he's used those on the X and Y axis, and actually this is correct.
I plugged in that formula, A or C minus A divided by A again, and it works out to 3.293.
So he says that he's used the formula for the flattening factor for his Z value. This is completely wrong. The Z value for the WGS84 ellipsoid is in fact the polar radius, which is 6,356 kilometers plus a few meters. So that's the fundamental error that he's made, using the flattening factor instead of using the actual radius for that dimension, that direction. But let's have a look at what he's actually used. Has he even used the flattening factor, and has he used that in any way that makes any sense? We have here 3.293 meters. Now let's look at what our flattening factor actually is. So the flattening factor is given by the formula F equals A minus C divided by A. And we can very quickly calculate this. The value for A is the equatorial radius, the value for C is the polar radius. Both values are given here in meters, and simply applying it okay, so that's A minus C, and we will divide by A again. we get this number. This number is 0.0033 and so on. This number is not a value in meters. Although both the figures that we plugged into the equation are in meters, this represents the relationship between the equatorial radius and the polar radius. Polar radius is just about 1/3 of 1% shorter than the equatorial radius. So if we were to convert this to a percentage, it would be move the decimal point 2 spaces, I multiply by 100, and we get 0.3352, so on, which is just about 1/3 of 1%. And that is the value of the factor f. Now the value given here is 1 divided by 298.25 and so on. If you actually calculate what 1 divided by 298.25 etc. is, you get this number. Okay, let's just do that. I'll stick that in the memory in case we need it later. And we take 1, we divide it by 298.257.223.560, and we get 0.003528106647812, which is, I believe, that's actually slightly different, but very close to this number here. So if I typed in the numbers incorrectly, perhaps at some point some numbers here are slightly out, but it's pretty damn close to the correct value. So this value, which is not in meters, is the value that Chris claims to have used in his equation. Now what he's done is he's taken this value and converted it, the equatorial radius, and converted it to meters. So he's divided this by 1,000 in order to get the number of kilometers. So if he's assuming that this is meters, he should apply the same thing. And what happens if you divide this by 1,000? You get this number. Now, those of you who are not familiar with scientific notation, this is telling you that the number in question here is 0.000003352812898 and so on. So can Chris please explain why he has a value of 3.293, is that, or 298? Not sure, can't see it too clearly, meters, when if he's using the f value, the flattening factor value, and he's applying it in the same way as he's applied the x and y values, he should actually have this number. A tiny, tiny, tiny number. If anything could illustrate the absurdity of the mathematical calculation that he is trying to perform here and claim is valid, this should be enough. Now, he goes on to claim that the plane that he has generated in the middle of this is what the WGS-84 really is, and he goes on to claim that it is 33 kilometers thick, when his own figures say that it will be 2 times 3.29 meters. So, I know, 6.6 meters thick. In fact, it should be a tiny fraction of that if his calculation was correct, but of course his calculation is absurd and wrong. Now, let's actually have a look at some ellipsoids and see what they actually are, what the flattening factor actually is. It's quite easy to draw an ellipsoid if you have a program that will do it. Here's one. And this ellipsoid has an equatorial radius of 6. So the x and y values are 6. And it has a polar radius of 3. This ellipsoid has a flattening factor, just like the Earth's ellipsoid has a flattening factor. And that flattening factor is given by the same formula. But of course the values that are inserted are different. So our value for the equatorial radius is 6. And our value for the polar radius is 3. Meaning that when we do apply those figures to the formula, we have 6 minus 3 divided by 6. And I can do that in my head. It's 0.5. This is telling us the relationship between the polar radius and the equatorial radius. The polar radius is exactly half of the equatorial radius, 3 being exactly half of 6. And this formula for the flattening factor simply has that function. It is simply describing the relationship between those two radii of the ellipsoid. We can create an ellipsoid which is exactly the same as the Earth. 6,378 kilometers. 6,378 kilometers. And a polar radius of 6,356 kilometers. Okay, I've left out the meters, small numbers here, but this is close enough for our purposes. And here we have that particular ellipsoid. Okay, it's almost a perfect sphere, isn't it? Hardly surprising, really, when you consider that the equatorial radius and the polar radius are almost exactly the same size. They differ by 0.33528 and so on %. That's 0.33528% difference. A third, roughly, of 1% difference in the length of the equatorial radius and the polar radius. That is the flattening factor. That is what the flattening factor represents. That is what it does. And any use of a flattening factor to replace the Z value in the drawing of an ellipsoid is completely false. There's no relationship to reality at all. If we go back to the ellipsoid I drew earlier, if we take this ellipsoid, this is the shape it is. If we had an object that was indeed this shape and size proportionally, would we be correct to say, let's apply the flattening factor in the Z axis? Would we be correct to do this? We had an object, we were holding it, we were looking at it, we measured it, and we drew it to scale on a computer program. We had an object that had a radius of 6 equatorially and a polar radius of 3. Is it in any way correct to say, no, you need to put the flattening factor as your Z coordinate and then you get the true shape of the object? No, it's not. The true shape of the object is this. It is what we started with. This is the shape of a completely different object. This is the shape of an object with an equatorial diameter that is the same as our first object, but a greatly reduced polar radius. It's a different object. It's not the same thing. It's not the thing we held in our hands. It's not the thing we measured the size of. It is something completely new, generated by simply applying a completely fallacious mathematical operation to the size of the radius. The flattening factor is not applied like that to the polar radius. The flattening factor describes the difference between the polar radius and the equatorial radius, period. Now, I think that's enough. I've talked down to people for quite long enough. I'm sorry to take the tone that I've taken, but for somebody who is a surveyor to be claiming that this math that he's done is correct is just ridiculous. It is utterly absurd. It is complete nonsense. He hasn't even been able to apply the very simple basic formula in the way that he said he had. Now, there is some later on in this video from Nathan's channel, there is some discussion about geoid and what a geoid actually is. And I'm going to make a separate video about that to try to explain what the WGS84 geoid actually is. Thanks for watching and listening. I dare say that my sensible friends who and subscribers, who most of whom accept the Earth is indeed a spheroid, will be horrified by the way I've been speaking. But I had to act as if I was talking to a class of adults behaving like 10-year-olds, which is, I'm afraid, the way that Nathan, Chris, Anthony and friends have been over this whole thing. So cheerio, look out for the one that explains what a geoid is.